Hey everyone, hope you guys are staying healthy, staying happy. I know it might be a little bit weird. Again, I've told you this before in other videos, but I'm looking out into my classroom and it's just a sea of empty seats. Wish you guys were here with me. Hopefully we get back as soon as we can. If you need anything, let me know through Google Classroom, whether it's about school or anything else, we are here to help. And you guys just, I do miss you. All right. We're gonna get into our part 2 of chapter 8 notes though, and we're gonna do 8.6 today. We're only gonna get through example 6. We're gonna break it up into 2 days, kind of like we did 8.5. Hopefully that really helps you out. Now, you guys are gonna copy the guided notes from Google Classroom. They're already filled in for you. I'm just gonna explain some of the harder problems. The biggest thing is you gotta know your properties. There are only 3 properties. There's the power property, the product property, and the quotient property. I'll show you how each of these could be used. All right, so I'm gonna skip 1 and 2 because I think they're pretty basic. Hopefully, if we do these, then you'll understand 1 and 2. But number 3, you guys, we want to expand it. Expand means make bigger. So when you look at your properties, you're gonna go from the left side to the right side. So the first thing I realize is that when I look at this argument, there's actually 2 things going on. There's a times problem and there's a power, but you gotta know where the power is connected to. The 3 is only connected to the x. It has nothing to do with the 5. So we can't use the power property yet. You have to realize you have to break up the times in the argument first. So we're gonna use the product property because multiplication and product go together. So this is gonna break up into a plus problem. And it's gonna be 2 separate logs. So you can put a log base 4 in the front, plus a log base 4 in the back, but you have to give them arguments. And the first factor, or the front part of multiply, goes with the first log, and then plus the second factor, or the second piece of multiply, goes with the second log, and that is the product property. But now I do notice that we can't do anything here, but this has a power. And since that has a power, what we are going to do is do the power rule for this one. The power of 3 can travel down in front and be a regular piece of multiply. So now I have log base 4 of, that's an ugly log, sorry, log base 4 of 5 plus 3 times log base 4 of x. That is fully expanded. We cannot do any other properties for it. Now when we look at number 4, I realize that overall it's a division problem. And if it's a division problem, I can use the quotient property, which says I can minus 2 logarithms. So I put log base 2 in the front, but I need an argument, which is the numerator, 9. And then I subtract log base 2 of the denominator, but I realize there's more than one thing in the denominator there. It's 7 times x. So even though I expanded as 1 step, I'm not done, because since there is a times problem right here, I can use the product property. So you guys, I actually have to break that whole back guy up. So with a plus sign in between 2 logs. So here's the way a lot of kids do it. They take log base 2 of 9, they keep that minus symbol there. And then they know that there has to be a plus sign in between 2 logs. So we're gonna say log base 2 of 7 plus log base 2 of x using the product property again, because that's a multiply problem, which means we can go to a plus problem of 2 logs. But there's an issue. It was minus all of that. So that minus sign just cannot go with the first part. You put parentheses around it, and now that will make everything okay. The other thing you could do is distribute the negative sign. It could be minus this logarithm, log base 2 of 7, and then minus log base 2 of x if you distribute your negative. So those are a 2-step expansion problems. Hopefully if you see these, 1 and 2 will make more sense to you. Now let's go the other way. We said in our properties here on the front page of 8.6 that if we start on the right side and go to the left, it's called condensing because you're making it smaller. So when you flip the page, you see 5 and 6 here. So number 5, you look at it first, and I want to point out that there's no rule for this. When there is a minus problem inside an argument, there's no rule. just kind of like I showed you here, that some people think if you have a plus, that in the argument you can do things. You can't. You can only follow the specific rules that are given to us. So there's really nothing that can go on there. But what I do realize is there's a plus sign in between two logarithms. And when there is a plus sign in between two logarithms, these two different logarithms can morph into a single logarithm. That's condensing. See, two logs become one log. It gets smaller. And when there's a plus sign, you just have to make sure you know what to do with his argument and his argument. And we have to multiply them because this is the product property. Again, make sure you're studying your properties. So I have to take 3 times x minus 4. Now, in all reality, these parentheses should be brackets. We don't like to put parentheses within parentheses, but it's good enough. I make this outer set larger. So this could be our final solution. But what math people would prefer you do is distribute the 3. So you guys, I would like for you to make sure that you write it as 3x minus 12. That would be the simplified version. All right, last example for the day. You look at this and some kids kind of jump the gun. They think there is a minus sign so they can use the quotient property. Well, we have to wait. If you look at the quotient property, again, flip your page back, pause the video, you'll realize that there's not allowed to be anything in front of the logs before you do the quotient property. So this 2 can't be there. This 3 can't be there. So we're not quite ready for the quotient property yet. You have to use your power property first. The 2 does not have to stay there. He can come inside as a power. The 3 does not have to stay there. He can come inside as a power. Now, on your notes, I wrote it out step by step, but in this video, I'll jump the gun or go a little bit quicker here. Log base 4, in your notes, I wrote 5 squared. Well, when the 2 comes in as a power, 5 squared is 25. Then there's a minus sign, and I have log base 4 of 3 becomes the exponent, using the power rule again, is x cubed. Now I can perform the quotient rule. When you have a minus sign in between two logs, it can condense to be just a single logarithm. So I have log base 4, but I have to make sure I know what to do with his argument and his argument. And the quotient property states that you have to divide them. So 25, or the argument of the first logarithm, is the numerator, divided by x cubed, which is the argument of the second logarithm, is the denominator. And now we have a very long log problem condensed into a single logarithm. And that is really going to help us out with our notes going forward. So you guys, in the grand scheme of things, expanding is good because it gives you a little bit of knowledge on the properties. But what is way more important is condensing. So you guys, I want you to make sure that on tonight's homework, you are independent practice. Because again, we're going to wait to turn everything in. Just keep really good organized kind of notes and independent practice, we'll call it. But really focus on these. Condensing, getting to a single logarithm is super important. Because if you remember from your 8.5 notes, our equations in 8.5 had a single log on the left side and possibly a single log on the right side. Because if we had those two different types of equations from 8.5, again, go back, look in your notes, or go back and look at those videos. If we have a single log on one side and not the other, we can solve that equation using 8.5 notes. Or if we have a single log on the left and a single log on the right, then again, we can solve that. So the key is, we're going to have harder equations coming up in this next part of the section, but we have to really know how to condense. I hope this helps. Make sure that you watch this video a couple of times. Pause it. Look back at your notes. See if it makes sense. And really try the independent practice. You can't get good without practice. It's your boy, Mr. P.